Hello everyone, and welcome back to a new video on our modeling, analysis and design of reinforced concrete building structures. Now, the last time we have checked that out was when we had discovered that was twisting in the structure. Now, I addressed twisting in a previous video, which I will be linking on the top right, and I addressed twisting as a theoretical topic, and it's time to put the theory here into practice. Also, in case you're wondering, and if you're new to the channel, this is part of an ongoing video series that is dealing with the analysis and design of reinforced concrete building structures, and I will link the list to the top right. Okay, so with that being said, sit back, relax, and enjoy the show. Now, a strange thing I noticed here is that this beam seems to be somehow disconnected from the plate. Now, if the beam is really disconnected from the plate or not is a mystery for me. I kind of am annoyed because I can see that the beam seems to be not connected to this column. So what I will be doing here is I might have to redraw this beam. As annoying as it sounds, I think this beam and that beam, both of them, so this beam and this beam needs to be redrawn. Because look, I can see a disconnect between the column and the beam. If I click on filter structure stories and double click on story, for example, 17, okay, I don't have anything there, story 16 at least, you can see what I mean by disconnect. Look at this. The beam here is not following the column here, despite it being or should be connected. Similarly, this beam. So I think I'm worried, and I somehow missed this last time. So let's fix that. Now, the fixing of this is not going to be easy, but I will have to do it anyway. Notice that it's a art itself or technique itself to fix something after you have modeled. It's much easier to model everything perfectly, but well, remember, it's our goal here is to make things as they are in real life. So I'll go to my thing here, to my mesh option, I'll delete the mesh so that I can be able to select things. So now the mesh should be deleting, and it did. Okay, the problem was this beam. It seems that this beam is not connecting well, and I don't know why. This beam was the same case. It seems because I have drawn it in one big chunk, it was not connecting, which is peculiar. I thought it should be connecting. Now let me remember something very quickly here. If you go to the analysis parameters, there is something called model generation, structure models. So yeah, it is doing a node at the vertical horizontal members. Not really sure why it doesn't discretize here. I mean, this is a vertical member and this is a horizontal member. It should make a node here. So I'm somehow puzzled. Well, what can we do? We have to delete and modify. So I'll open the section very quickly here, and I'm gonna try do some magic here. So my goal is to select this beam in all the stories, delete it, and redraw it. So how can I do that? Well, I'll go to my selection tool. I'll go to geometry first, and I will ask it for the x-axis from so to so. So what I'll be doing is I'll click here, hoping that takes it. It doesn't take it. Okay, but I have to do it myself. So what is the x-axis of this point? I have no idea. Let me just click on it and see. This should be a node. X 48.67. So I'll tell him for the x-axis from 50 to the x-axis of, and I want to see. You see, I'm trying to select by geometry now, which is a cool trick that I will be using this time. This has an x-axis of 30.85, so there we go. Now I should be flipping that. So this is 30 and this is 50. Let me try that now. Let me apply it and see what happens. So if we click on apply here, no, it doesn't select everything I want. It does not select everything I want. So I think I failed. Okay, let me try again. So what is the coordinate of this node? Let's remove the section very quickly. Let's walk here. So this is 50.22. Ah, okay, I messed up here. So let's say 50.1. And let's apply the selection again. Okay, we are still not selecting it. It was 50.2. So let's apply 51 and select again. So trying to select again, yep, this time I got my target beam selected and other things selected. Okay, so we're doing progress. Now, I want to also apply a filter for the Y. So let's just once again stop on that thing. This is at 13.78, so I want it from 13 to 14. And I think now I should be able to select my beam. And there we go. Now the problem is it selected the beam and it selected the column, because you can see that both the columns and the beam is practically satisfying the condition. Now here I can use a cool trick, because this is good and all, but I can also add to this me having a different beam and a different column section. This here is called CR 300-500, and this here is called BR 300-500. So what I can be doing is I can click on this to select. So now it's selected everything in the X between 30 and 51 and the Y between 13 and 14. And then I can remove everything that has this column section, CR 300-500. How do I do this? While I'm selecting in the selection tool, I can go to attribute and select the CR, I think it was 300-500, right? I can select the 300-500 and push the negative button here. If you do that, you deselect the columns, and now I have my beams. As painful as it sounds, I'm gonna push the delete button now, because I have to redraw it again. It's usually very painful when you have to delete things, but, well, such is the nature of civil engineering. So, there we go. Push the delete button, and yep, the beams are gone. I need to do the same thing for this dude, so let's do it. This one has a Y of 18.75. So I think I can do the same thing here. If I go to geometry, it delete everything. Okay, fine, I'll just do it again. 30 to 50. So just apply that to see if it's working. Yeah, at least got that right. And then I let him select, what was the Y? 18. So from 18 to 19. And apply that. There we go. And now I should have all the beams and all the columns in that domain. And yes, I do. Now, once again, I need to filter the columns out. So I go to the attribute, select this, and hit negative to remove everything that has the column section. Now I'm ready, and as painful as it sounds, I'll have to hit the delete button again. It really pains me, but it is what it is. You see, we are keeping it real here in the Civil Engineering Essentials channel, and those errors are part of, well, your everyday life. Okay, now let's try to solve this issue. So I think that the beam was the same everywhere, so at least that's good news. I can go again here and draw another beam. So let me just click on that to understand. This is 300-500, I guarantee. Yep. So I'll have to redraw this again. I select the beam, say reinforced concrete beam, 300-500, and this time I'm not gonna dash one straight line because it seems it did not connect. And maybe that's the reason why I had big deflections. Because the largest deflections were here, and it seems that because the beam was disconnected from the slab, it seems that it did not help the slab in its carrying of its deflection. Well, who knows? We have to do it ourselves. So I will click one click here, and I have my drag on. And now I'll be very careful not to misclick, because you know the idea. It's very painful if you misclick. So let me just remove the section to be absolutely sure. There we go. That's beam number 1. See, now I'm drawing it using 3 pieces because I learned my lesson. I am surprised, like I was assuming that robot should be able to mesh it because it does every time, but this time my assumption seems to have not worked. Now I have this dude. I'm gonna draw the other one now. And once again, I'm going to draw it in such a way that it connects piece by piece. So I click here, and I click here, and so on. Now, before I start copying this in each and every story, I want to do a dry run just to make sure that I don't want to make a problem. I don't want to do everything and then realize that I messed up and then go all over again. So that's usually what I do. Like in real life, when I'm not doing robot theory or tutorials, back then when I was a junior engineer, I was actually, every time I do something, I was hitting the run button just to make sure that it makes sense. Now, of course, the run button now became really costly because our structure became bigger, but, well, we'll have to wait. Of course, the editor is going to edit this waiting out, so I have a separate structure, which I will accept. And I will get a bunch of warnings, and please notice that I already addressed the warnings in a previous video, which I will be linking on the top right. And I have talked about this, so I'll leave it now. What I want to do is I want to see if it deflects or at least follows the deflection shape. So, yep, it does. Okay, it does. That's good news. Now, don't worry that there seems to be a disconnect between the beam and the slab. It is just a graphical issue here, and now I'm sure, and I can tell you it's a graphical issue, because you see the slab has multiple points in the center which are discretized and can deflect, whereas the beam in the graphical engine is only deflecting at its edges. And I can tell you that because I program finite element programs myself. You can kind of see the effect of the beam by looking at the deflection. You can see that the slab is stiffer just on the beam line because the beam exists, so that's a good thing. And the issue that actually uncovered this error that I had was that the beam here was disconnected from the column, something that should not be. So now it's not disconnected, so now I can live in peace. Now I still have the twisting and torquing of that structure to deal with. So okay, I'll just now select both beams, and now I'll do some copying. So I'll just select that. Now I'm pretty sure I messed something up because I think previously I had some groups, and I'm pretty sure that I had some grouping based on slabs or something. So I have a big feeling that I messed something up in my groupings, but that's fine because I can still select using geometry. So that's still a silver lining, I guess. I'll unlock and go to mesh and delete the mesh so I have a better chance of selecting the nodes correctly. Of course, it's deleting the mesh. And for some reason, it selected everything, which is kind of cool. I have to select my beams again. And there we go. And now I have to go through the painstaking phase of copying that thing multiple times. Everybody knows the feeling when something goes wrong and he has to do this over and over and over again. Trust me, it happens to me a lot. And by the way, if you want to copy, you go to Edit, Edit, Move, or Copy. Okay, so I'm copying those now, each story. You get the idea. I could make a multi-copy. I could make number of repetition, but if I remember correctly, my structure had different story heights. So if I do number of repetitions, then I would end up having beams mid-height because some stories are different than the others. So I want to go in the safe side, and I just want to do it story by story, just to make sure that everything is fine. And then, of course, I have to run again and deal with it. You see, I was going into this video aiming to make a quick video about how we can just increase or strengthen some columns, but it turns out that, well, you know the drill. Every time CE thinks that the video is going to be easy peasy and something simple, turns out that the video is full of stuff. So, okay, enjoy it while it lasts. Okay, yeah, I think we're done. Yes. Okay, so moment of truth, let's run again and see that it's connecting or not. Okay, so the analysis is complete, and I want to see if the beams are deflecting together or not. So let's just open the deflection shape, take a look, and yes, everything checks out. Great, fantastic. Okay, now we have checked out and finished the problem of the beams not connected. Okay, so continuing our efforts, and this is day 2 because in the last day I actually recorded this beam thing, the problem with the beams, and now we are back to continue the problem with the twisting of the structure. So to understand where exactly the problem is, of course, I had a previous video, and I think I linked it in the beginning of the video, where I was talking about how unsymmetric supports could cause the structure to twist under its dead load. And if you open the sections, you can see that, well, it just happens to be that. Now, there are two types of stiffnesses that I need to include. I need to include stiffnesses from shear walls, and I need to increase the stiffnesses of columns. So to understand this, I need to go to my trusty pane. Alright, so taking a look on our paint, this is my structure, and the structure seems to be twisting in this direction, as it seems. So it's twisting in this direction, which means that I have some weaknesses on the bottom side, and I have some weaknesses on the right side. So this should be the most effective domain to start with. And then after I start by stiffening this domain, because I mean, look, twisting means it goes down, it goes right, you can see it here. If you go to top, you can see the structure both going to the right and going down, albeit with different rates, and that's why the structure is apparently twisting, but it's a real nightmare and I have to think about this. So I'm thinking to add something that stiffens in this direction, first of all, and then I will see what I will do with the bottom side. So what I'm doing, first of all, to see the progress and to understand what the problem is, I will first of all remove the deflection shape and select basically the nodes. For example, this node. Now this is actually a balcony, so I mean it's already not stiff. So let me just select a point that I know is really stiff. And the point I'm selecting is the shear wall. If you stop on the shear wall, this is thickness 200. That's a little bit too low for a shear wall. I might need to make it thickness 250. The slab is 200 too. Really? Let me just check. I mean, I might increase it. So to do it the right way, everything seems to be 200, right? Even the slabs. Okay. This is also is it 200? Yeah, there we go. Everything is 200. So now, of course, I want to focus on this structure because it's the bigger one. So what I will be doing is, well, I will select the elements first of all and increase the thickness to 250. That's the first step to see how the structure reacts. Remember, I still have not added any shear walls. So I'm selecting the elements, being very careful that I do not select the bridge. No, I have not selected the columns, but I don't care because I want the slabs now. Okay, so I will define me a thickness 250, so I'll add me a thickness. I need to study the reduction of the moment of inertia for the walls later. I will reduce it now to be on the safe side, but I think the reduction of columns might apply and might not apply on shear walls. It depends on how much the moment is in relation to the axial force and how much the cracked section is. So I don't have a clear solution for that right now. But what I will be doing is I will just do it for now to be reduced. And then I will think about this later. So 250, first of all, I'll add that. And now I will click here. Now I know that those are selected, but it doesn't matter because it will apply on all the plate elements. And I want to apply it on everything, even the slabs, because it seems I used thickness 200 as a placeholder. So let's stiffen the structure a bit, because like I need a real structure before I can judge how much it twists. Like it might be just an issue of stiffness. Okay, let's delete the mesh and let's run again so that I get a read of the deflection of the structure. And notice I'm doing this on top of my head. I have no idea what the result would be, except that my editor, of course, is going to cut this runtime. You can notice that in this day, we are on the 12th of October. Yesterday, I basically found out an error, and I was like busy fixing that. That's why the editor got angry, and I have not provided the video that I promised him to provide on Wednesday. Turns out I had a very bad schedule this week. Now, as I said before, I went through most of the warnings you will see here, so I will not address them. There is no error. Those are warnings I have talked about in the previous videos, so I will leave it as is. And now let's just open the deflection and just take a look on the deflections. So, okay, fine. Let's now go to top, maybe, and just remove the deflection and select this node so that it is going to be our benchmark. Now, I'm trying as long as I can to keep it code independent. So the idea is that there is limits on story drift that you have to attain So a twisting structure, of course, means that you have a total drift in the horizontal for the full structure and a relative drift between the top and the bottom of a story. So let's try that. I will just remove the deflection and I'll click on this thing here and I will go to results, displacements, and I will see the lateral displacement for the dead load. Let's see. Now, of course, the lateral displacement, the dead load, is a disaster. It's 16 in X and 25 in Y. Now, you still have to measure this in terms of relative drift and so on. But I will just show you now how to reduce those numbers. And of course, I'm not going to target a certain range because I try to keep it code neutral. You should refer to your code and see how much you are allowed to have interstory drift and absolute drift. To get the interstory drift, my approach is usually to find 2 points, or not in balconies, like this and this, for example. I'm holding the control button and selecting that point now. So I have 2 points now. I remember 2475 and 2503. And then I go to results, displacements. And I just check out this and check out the other one. And basically to find the drift, you can see that's not really much, by the way. Like this here is 14.9. Of course, mind you, this is in the dead load only. 14.9, and this is what, 16.9, so 2 millimeters. So it might not be a big deal, but I will show you how I can reduce this anyway. Just in case that you have a certain stricter code or something, and you need help to reduce the amount of twist your structure has. So based on my previous talk here, I think I will be adding something here, a shear wall or something. That's my first thing I would think about. So in Autodesk Robot, I'll just go and see. And yeah, I have only 2 shear walls here, as you can see. And I have nothing here. There is an eccentricity, because you can see that this is really stable here. And if this is the center of mass, and those are here, I need something in the other side of the center of mass. Now, mind you, the planning of shear walls is more sophisticated than that. You would have to place and calculate something called the center of rigidity, but that's something I will be maybe explaining in future videos that talk about, for example, earthquake engineering. Now here, because I'm a little bit in a hurry, because I have other things I want to record, okay, so after a grueling task, I think we are ready. Now, to remind myself, I think this was 25. I think it was 20-ish or something, or 22 or 29 or something. I forgot. I just noted while I was doing my video that I'm almost at 3K. Wow, that's really encouraging. Okay, back to this node. Okay, it's called 2811 now. The number has changed because there are new nodes due to the shear wall that I have drawn. So I go to results, go to displacements, and take a look. Yeah, see, in X now. Oh, this is lovely. Look at that. Look, I think this was more than 10, maybe 14 or 20. I forgot what the number is. Yeah, this makes me look like a noob. I know, I totally forgot the number. But it was definitely not 2. Definitely. So there is a massive reduction in the X movement here due to the fact that this shear wall caused some stabilization effect on the right side. You can see immediately the immediate effect of that. So let me just see. There we go. Yeah, I think. Okay, of course, let's take a look on the deflection shape. There should still be twisting because I saw in the Y a lot of movement. Like I saw in the Y there is still 19, so that's still a problem. But I think in the X, it should be satisfying. So let me just see, or at least it should be okay-ish. Let's take a look. I can't see anything, right? Oh, look. It's quite improving. Like, let me just see. Yeah, I think it's quite improving. Don't be freaked out by this. This is a scale thing. Now we are still twisting, but at least the left-right motion has been reduced. What I have here is a downward motion, and what I have here is an upward motion. Now this makes sense because I think I know why. There is no staircase here, and the staircase will cause some stiffening of the structure. Now it goes up a little bit because this is stiffer than this. This goes down because this is stiffer than this. Why? Is there too many shear walls? Yeah, there's the elevators. Yeah. That's stiffer. Also, something else I noticed is that I put columns which are really meek and weak. Like the columns are 300 by 500. Who does that? Like 300 by 500 for a multi-story? That's really weak. So what I will be doing now, well, that's gonna be a big nightmare. I need to increase the stiffness of the columns first. So how do I do this? Well, I have no idea, to be honest. Okay, let me think about this very quick. Okay, so what I will be doing is I will have for the first 5 floors, for example, I would have a certain column thickness, and for the second 5, another column thickness or area, and the third 5, another column area, because I mean, it should be like that. This is how we do it. Okay, so how can I do that? I need to do some selection magic. So I'll go to select. First of all, this is, I think, BCR or something. So I'll go with CR500 and add that to the selection. Of course, it's selecting. Oh, okay, good. It's only selecting those. That's good. I think it's much easier than I thought. In the bottom, I will have it to be. Now, the problem is that there are 2 bottoms, right? There is a bottom below the car park and there is a bottom below the structure. Oh my, that's gonna be interesting. That is gonna be interesting. So for those, 300 by 500 is okay. For those, maybe I think 3 slabs are okay, or 4 slabs. But those, absolutely no. Those are too weak. And those columns might be okay-ish up to the slab, but those columns are weak. Because, I mean, this column needs to carry all those stories, so I need to limit my selection to the geometry. So I'll go to top and just rotate a little bit. Okay, I lost orientation. Let me just be a little bit orientation. Okay, there we go. And I need to select those dudes. So I go to geometry, and I can actually do a trial and error thing. So I select Y, and I think that's the Y, right? Okay, so I'll just stop here and take a look. It's around 3. So let's select from 3 to 50, and it's selected correctly. If it did not, you can go to previous, which will undo the last thing you have done. It's kind of your undo button. So those are the columns here. Now, I know that the corner columns should be different from the interior columns, should be different from the edge columns. I might do that. I will see what happens. Okay, I don't think I need this. I don't think I need this column because it's not carrying that much. I will keep it anyway. I might change it. Okay, so let's go to the column section. And let's add us a 700 by 700. Oh, there it is. 700 by 700. I think this makes sense because I have like 17 stories. I'll apply that. So now, of course, it's increasing this section of the columns. It does. There we go. Now they are fatter. Of course, this must go back to 300, 500 because it's not carrying a lot. So we should also consider this, and we don't want to be wasteful. I am giving you the principles of this. I'm not doing an exhaustive research here. I'm giving you the keys of modeling, analysis, and design of reinforced concrete building, and talking about all the points that come into my mind while I'm doing this. If I want to do this for a commercial work, it would take me like 3 nights or something of non-stop work. But since I'm explaining that, it takes me more time because I have to convey my message and my thoughts to you via words. Okay, so I increased the columns. Okay, and now I will select previous again. So that's my previous selection. But wait, I want to reduce the columns that are Like, let me see. So 4 floors, 4 floors, 4 floors, and 2 floors. Okay, I will reduce from the 5th floor onwards. I will reduce from here. This has a z, and how do I know what z I have? If you stop on the node, you can see coordinates showing here. So I think this has z of 13. Okay, so I want everything above 13. So I'll go here and go to geometry. Now I don't need this and I don't need this, but I need everything above 13. So let's say 12.99 all the way until 100, and let's AND that. Okay, I think I have my columns. Yes, I do. And now I will change the section of that again. So for those, I will choose 500 by 500. I think I have defined it. There we go. Let's make it 550 by 550. So 550 by 550. You need to know that you cannot just haphazardly reduce column sections. There is a limit of the... Now, you should check out your detailing logs and detailing codes, but there is a limit of how much offset or shrinking can do for a column, because you have to, of course, converge the reinforcement bars. So yeah, keep that in mind. I'll add that, close, and apply this to those dudes. There we go. I think I applied it. And now I will select the previous again. But this, okay, it selected everything, it seems. Okay, so I have this. So 1, 2, 3, 4. So from here upwards, what is this? This is 25. So I will select from 24.9 all the way to 100 and this. And I will do those to be 400 by 400. So let's go here. And this is how I do it. Of course, what I am missing and what I want you to do is to change the section of the corner columns and change the section of the edge columns. But I mean, I gave you the tools that enable you to do that, so I think I'm warranted to delegate some of it to you. So 400 by 400, 400 by 400, there we go. I'll add that, close, and apply. Okay, so I modified my columns a little bit. Now, this might not solve the problem, but at least I think we're approaching a way where we are basically getting better and better at this. So let's run the analysis again. Calculations. Okay, now the analysis is complete. Let's check out this and see what happens. Okay. I can see something strange here. There is a huge downpour here. This might be, wait, is this just a scale thing? Let me just unscale and scale. Because I don't want to be tricked by the scale. Yeah, it's a scale thing. So don't trust the first shape because it's a scale thing. And okay, how can I make sure if it's working or not? Well, let me go to top. Okay, it is getting a little bit better. I'm not sure. Now, the way we can see this is to go here and let's remove the deflection shape. So I'll select that now, and I will go to results and displacements and see if it went down. Yeah, I think the Y got down a little bit. So how would I analyze that to understand? Because in the end, I would just do it off screen, but let me just show you how I would analyze this. So I would approach this by looking now, and what I do usually is I subdivide my structure into 4 quadrants and ask myself questions for the structure globally and for each quadrant individually. So first of all, it seems that this quadrant alone is okay. I don't see much differences in the quadrant itself, so I would accept that. Let me just use another color. This is amazing. I have a problem with this quadrant, it seems. And I think the entire half here has a problem. So I think my problem area is this one, and my problem direction is Y. So I mean the up-down direction. So this is how I would look at things. And that's what I do. Like, this is why this is how I teach in Civil Engineering Essential Channel. So I hope you don't disagree. I don't want just to keep trying forever and then hoping that something works. There must be some analysis. Okay, so you can see that the problem has gotten less, and the situation has improved by reducing the lateral deflections, and as well as reducing the twisting, and as well as reducing the relative displacement of the structure from each story and the other. So at least now we know exactly how we would do that. However, first of all, I will not be able to eliminate the total twist. First of all, because inherently there is twisting. That's the first thing. And the second thing is because even if I eliminate the twisting now, once I model my staircases, the staircases are going to provide extra stiffness that might cause the twisting all over again. So I'll have to wait to finalize this issue in other videos once I model my staircase. But, well, I think my objective has been achieved, immensely reducing those lateral twists. I think I even halved them. And I've explained to you my thought process, so that's a good takeaway if you want to take away something from this video. Alright, so that's everything I wanted to talk about today. Thank you very much for watching. And of course, before I finish, I want to give a balanced structural shout out to our dear channel members whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos on time, hopefully, and with a certain quality I try to achieve, and for that I am forever thankful. Of course, and as per usual, I hope that you enjoyed the video and that you found it beneficial. Of course, if you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, etc. Especially subscribing, because it helps to increase the reach of my channel, and we are approaching 3,000 subscribers. So that's another milestone we are meeting. With that being said, and as per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.